Assalamualaikum warahmatullahi wabarakatuh, and hello for my friends and our lecturer, Madam Sitawa. We are from group 2. For this video, we are going to present about the differentiation in chapter 2. Before we start our present, I want to introduce my group member. First, my name is Raja Muhammad Afiq bin Raja Rafizi. My metric numbers 01 DGU 22F1009. And the next one is Muhammad Azri bin Azmi. His metric number is 01 DGU 22F1006. And the last member of our group, which is Muhammad Faiz bin Jameh. His metric number 01 DGU 22F1014.
My name is Muhammad Faiz, and I will explain about team roles and responsibilities. Okay, first my role is team roles and responsibilities, and explain question 2. And Afiq is explain about introduction of members, explain question 1 and edit video. And last is Azri, is introduction of differentiation, and example of application and summary.
Hello, my name is Muhammad Azri bin Azmi. I want to continue introduction of differentiation. Differentiation is usually used in solving problems, especially in engineering, medical, commerce, agriculture, and many other fields. When you find the rate of change of a quantity with respect to other quantity, you are actually doing differentiation. Another name for differentiation is the derivative of the functions. If a person is running up a hill, his vertical height will change with respect to his horizontal height. This rate of change of vertical height with respect to horizontal height is called its gradient. Next, example of application of differentiation in real life. Number 1 is determine speed or distance coverage, like velocity and acceleration. Number 2, check the temperature variation. Is a main to check the pandemic virus and more. Number 3 is calculate profit or loss in business. This is the common in real life. For have the economy stable. The application of differentiation in real life, which is related rate, like two people. Number 2 is the boys blow up the balloon. Number 3 is any animal. Okay, I want to continue to the related rate. The objective of related rate, number 1 is to use knowledge of the derivative to solve related rate problems. Number 2 is to find the rate of change of one quantity, knowing the rate of change of another quantity. Number 3 is to find the rates of change of 2 or more related variables that are changing with respect to time.
Okay, for the question 1, explain the solutions to find the stationary point for the equations is y equal to 5x power of 3 plus 2x power of 2 minus 7x minus 2. and determine their nature of the points. Sketch the graph. Okay, solution for question 1. Solution for the question on the side. Step 1, dy per dx equal to 15x power of 2 plus 4x minus 7. And next, step 2, dy per dx equal to 0, and we put 15x power of 2 plus 4x minus 7 equal to 0, and then we calculate EQN. For the A we get 15, and for B we get 4, and for the C equal to minus 7, and then we can get answer x1 equal to 0.46 and x2 equals to negative 0.83. Step 3, we want to find answer for the y. First, we substitute x 0.56 into 1, which is y equal to 5x power of 3 plus 2x power of 2 minus 7x minus 2. Then we can get 5 in bracket 0.56 power of 3 plus 2 in bracket 0.56 power of 2 minus 7 in bracket 0.56 minus 2, and then we can get 0.88 plus 0.1663 minus 3.1992 minus 2, and then the answer we can get minus 4.41. And for that, after that we can get stationary points equal to, in bracket, x is 0.56 and y is minus 4.41. Okay, next we substitute when x minus 0.83 into 1, then we can get y equal 5 in bracket minus 0.83 power of 3 plus 2 in bracket minus 0.83 power of 2 minus 7 in bracket minus 0.83 minus 2, and then we can get equal to minus 2.86 plus 1.38 plus 5.4 plus 5.81 minus 2, and the last answer we can get 2.33, which is stationary points equal to, in bracket, x equal to 0 minus 0.83 and y equal to 2.33. For the next step, step 4, which is determine nature. Okay, we now test the second degree differentiation. D power of 2y per dx equal to 30x plus 4. We substitute x 0.56 into y equal 30 in bracket 0.56 plus 4, and the answer is 20.8. 20.8 is bigger than 0, which is its minimum point for the sketch graph. And then transfer we get in bracket 0.56 and minus 4.41 is minimum point. And next we substitute again another x, which is x equal to minus 0.83 into y equal to 30 in bracket minus 0.83 plus 4, and the answer is minus 20.9 is smaller than 0 and which is we can get graph for the graph is maximum point, and the answer in bracket minus 0.83 and 2.33 is maximum point. Okay, for the graph, first intersection for x-axis y equal to 0. Okay, 0 equal to 5x power of 3 plus 2x power of 2 minus 7x minus 2, and then we can get for the answer x equal to 1.14 and minus 1.26, which is in bracket 1.14 and 0, and another one is in bracket minus 1.26 and 0. The next one is intersection for the y-axis, which is x equal to 0. Okay, y equal to 5 in bracket 0 power of 3 plus 2 in bracket 0 power of 2 minus 0 in bracket 0 minus 2, and the answer is minus 2, which is in bracket x 0, and for the y is minus 2.
Okay, I will explain the equation 2, and the question is explain the solution to find the stationary point. For the question is y equal negative 5x power of 3, negative 2x power of 2 plus 7x plus 2, and determine their nature of the points and sketch the graph. Solution for the question on the side. Step 1, dy over dx equal negative 5x power of 2, negative 4x plus 7. Step 2, dy over dx equal 0, 50x power of 2, negative 4x plus 7 equal 0. EQN, a is negative 50, b is negative 4, c is 7, and x1 is 0.56 and x2 is negative 0.83. Step 3, want to find y. When x equal 0.56, y is negative 5 power of 3, negative 2 x x2 plus 7x plus 2 equal 5 in bracket 0.56 power of 3 plus 2 in bracket 0.56 power of 2 negative 7 in bracket in bracket 0.56 plus 2, and equal is negative 0.88, negative 0.63 plus 3.92 plus 2, and the final answer is 4.41, and SP is in bracket 0.56 and 4.41. When x equal negative 0.83, y equal negative 5 in bracket negative 0.83 power of 3, negative 2 in bracket negative 0.83 power of 2, negative 7 in bracket 0.83 plus 2, and equal 2.86 negative 1.38 negative 5.81 plus 2, and the final answer is negative 2.33, and the SP is station point in bracket negative 0.83 and negative 2.33. Okay, step 4, equal determinature. D power of 2y over dx equal negative 30x plus 4 when x equal 0.56, y is negative 30 in bracket 0.56 negative 4 and equal negative 20.8 smaller than 0 in bracket max point, and then 0.56 and 4.41 is maximum point when x equal negative 0.83, y is negative 30 in bracket negative 0.83 negative 4 equal 20.9 bigger than 0 is mean point, and the equal in bracket negative 0.83 and negative 2.33 is minimum point. Intersection A negative axis in bracket y equal 0, 0 equal negative 5x and negative 2x power of 2 plus 7x plus 2, x is negative 1.26 and 1.14 in bracket negative 1.26 and 0, and in bracket 1.14 and 0, and y negative axis in bracket x equal 0, y is negative 5 in bracket 0 power of 2 negative 2 in bracket 0 power of 2 plus 7 in bracket 0 plus 2 and in bracket 0 and 2. Y negative axis in bracket x equal 0, y equal negative 5 in bracket 0 power of 3 negative 2 in bracket 0 power of 2 plus 7 in bracket 0 plus 2 equal 2, and the final answer is 0 and 2 in bracket.
Okay, the last summary. In this chapter, we will examine many applications of differentiation. We learn to find the maximum and minimum value of functions, and this skill allow us to solve all kind of problem where we need to find the maximum and or minimum value. Our differential skills we be used to create graph, and we will use differential to approximate function value. We will also use differentiation to study elasticity of demand and exercise tariffs. Okay, I want to say thank you for watching this video from my group.